Hi, welcome to the International Space Station Flight Control Room. I am here today with a special guest to talk to us a little about some testing that was taking place this week on Monday and on Wednesday. It was on a Suitport. Suitport is a new technology that is being developed here at the NASA Johnson Space Center that will eventually allow astronauts who go out on a spacewalk to do that without going into the airlock. So here with us is Rob Boyle. He is the project manager of the Suitport, and welcome. Thank you for coming. So before we get into the Suitport and what all that is, I want to talk a little about you. So tell me first, how in the world did you make your way here at NASA and then to be working on this cool technology?
Mechanical engineer from Texas A&M University. Uh, Came out and got one job. Was able to move to JSC in 1990. Have worked spacesuits for about 13, 14 years, mostly on the life support backpack. Mostly a specialist on the life support backpack. And then when return to flight came on, I worked the goo gun for repairing the bottom of the ship.
The goo gun.
And then I worked. Then I've moved around a little. Worked the Altair lunar lander during the constellation phase, and now I'm working through the advanced exploration systems. I'm working Suitport.
So you've been working on some really fascinating, interesting things. What was it? I mean, were you always a space, had some interest in space, or how did you
Well,
make your
I've
way
always
here?
had an interest in space. Yes,
Hmm.
anybody who grew up or was young when the Apollo landings were happening had an interest in space, and so I always had that. Um, and once I got to JSC and started working on the spacesuit, I fell in love with EVA. So if you look at all those tasks, they're all EVA centric. They all involve what would we do while spacewalking.
And by EVA, you were talking about a spacewalk,
Spacewalk.
the
Yep.
extravehicular activity.
Extravehicular activity.
Okay, so now let's get into Suitport. I briefly explained it, but can you go into a little more detail about what the Suitport is?
Sure. The Suitport is to replace the traditional airlock on a spacecraft. So what we can do is we can hang the suits off the side or the back of a spacecraft, and that allows us to have the suits ready, pressurized, and the crew members can open a spacecraft door, open the back of a suit, assuming it's a rear entry suit, and jump in. So they can jump into the suit, close the hatch on the spacesuit, close the hatch on the vehicle, and very quickly depress the space between, which we call a vestibule, and walk off the spacecraft. So you can imagine in an asteroid, if they were exploring in a small vehicle and they said, "Ooh, I want to get that rock," instead of what we do on space station where it takes a few hours to get out, they could just set their drink down, go jump in the spacesuit, go get that rock, put it on the back of the spacecraft, back in the spacecraft, and they might only be out a total of an hour.
Wow,
So
that is
that's what
so
we're trying to do.
so far out, and I really am just so intrigued by this technology. So it's a lot of fun. But now also there are other people who are interested in this. So we asked Twitter, and we have a few people on Twitter who came up with a few questions. And just very simply, the first Twitter question comes from IB Happy Hopi. How do they do that?
So the way we do that is we've designed a clamp system. It's similar to what's used standardly in spacecraft and sea operations as a Marmon clamp.
Mm.
And so that is where a couple of clamps come in and they clamp the spacesuit to the vehicle. One of the innovative features, how we've implemented that clamp, is we don't have to compress an O-ring. Our standard hatches all use tremendous clamping forces. I can't do that on a lightweight spacesuit that I want to be able to move around and walk on the moon or be on an asteroid or do whatever. So what we've done is we've replaced that O-ring or that seal with something similar to a bike inner tube. So after we clamp it to the spacecraft, we inflate a seal against the spacesuit, between the spacecraft and the spacesuit, and that allows us to seal the suit to the spacecraft. Then we can open the doors and come in. So there was a lot of innovation that made this possible by a lot of people.
Wow. And so how long have you been working on this project, and how long has the project been in work?
So the project Suitport was patented in 1989, actually,
Okay.
out at
Wow.
Ames. So it's been around for a long time,
Mm.
but it needed a home. It needed a spacecraft to be on. So when they started working, originally the lunar rover and now the multi-mission space exploration vehicle,
Mm.
um, when they started working those vehicles, we realized that, hey, we could really change the operations that the crew do in space, and we could make exploration really efficient if we had that Suitport. So we put some mock-ups on the back of those vehicles, And those vehicles have really been able to show how cool it would be to have Suitport, what we could do with it. What we're trying to do in Chamber B, what we're doing with this week's testing, is not what would we do with Suitport if we had it. It's can we really make Suitport work? For a couple of years, we tested it assuming we could make it work. Hey, what would we do if we had it? Now we're really striving to show, yes, I can pressurize the spacesuit against a bulkhead. I can put a crew member across that bulkhead. I can separate them, depressurize that pressurized seal, and I can step off the wall. And we did that both Monday and Wednesday. And we've done glove boxes before, but we've never had a human don a pressurized suit.
All right, so this was the first test that it was a manned, because I know we did an unmanned testing, last, in
a couple
June,
weeks
the early
ago.
part of June?
Yep, we did an unmanned test. We put a blanking plate, or just a big aluminum plate in place of the spacesuit. And we went ahead and ran the Suitport through its paces. That made sure the test team knew what they were doing, that checked our procedures out, and it made sure all the hardware was in place before we put a human in the loop. And then we came back this month, we added the spacesuit, repeated all that without a human again, with just the spacesuit in place, and then prototype spacesuit, the Z1. And then we dropped a human in, and we've had 4 test subjects so far, and we've had a lot of fun with it.
Wow, very well. And so I assume the testing went well.
The testing did go well. The one thing we learned, it's harder to get out of the spacesuit than we expected, and so we have another test series we're going to try in September, and we'll have different spacesuit doffing aids for that test, so that we're able to assist the crew members much, much better in getting out of the suit.
Okay. Well, great. And so that leads me to the next Twitter question. This Twitter question is not one question, it's like a lot of them, so be prepared. I don't know how they got this in 140 characters, but we'll go with this one. Will the visor have a heads-up display? Why are we currently fitted in an airlock? And what are the other benefits of the Suitport? Safety, convenience, time, and is the suit used more than one mission?
Very good. So the first one, why are we fitted in an airlock? So for like space shuttle or space station, you don't want to depress the entire spacecraft. You want to depress a very small area of the spacecraft and let them go EVA from that. You also don't want all the crew members to have to put on a suit. So like on space station where we might have, or space shuttle where we might have 7 crew members in the spacecraft, I only want to send 2 people outside. So I put those 2 people in the airlock, I'm able to depress that and go out. On shuttle, the suits actually, I believe we built 18 suits total, and we've done all of the shuttle. We did all of the shuttle missions, and we've supported all of the ISS US EVAs with those 18. That's life support backpacks that we built. The suits last about 8 years, and we do numerous EVAs on them through those 8 years. So that's for shuttle and station. For exploration, it'll depend on the mission. It'll depend on whether we have the downmass to bring the suits back, or whether the easiest thing to do is, like on Apollo, they kicked the life supports out the vehicle just before they took off and left them on the surface of the moon. I've seen some pictures of them laying there. It's kind of neat.
Wow.
And so we may have to do that for exploration missions where we're mass constrained, or we may be able to bring the suits back. What were the other 2? There were 4.
So we have also, we were talking about the benefits of safety, convenience, and time. What are the benefits of the Suitport? Why not just use the airlock that we already have?
What we're really striving to do, we think we can get them out of the craft in under 30 minutes compared to the 4 or 5 hours that it takes us to get out right now with conventional airlocks and conventional non-rear entry suits. So we need the spacecraft to use an 8 psi atmosphere instead of the 14.7 we have here and on station. But if we can get an 8 psi vehicle, then we think we can get them out in under 30 minutes. And then our second goal is to reduce contamination brought back into the vehicle. You've probably seen pictures on Apollo when they explored the moon, how much dirt came back on the suits, how much regolith came back with the suits. You can imagine in an asteroid where there wouldn't be gravity to resettle any dirt or regolith we saw, that you might have an electrostatic cloud of dust around you. If you brought that into an airlock, it's coming into the spacecraft. If I use a suit port, the only piece of the suit that comes in is the nice slick back part of the life support system. So I significantly reduce the contamination that comes in. And you can think of that in terms where we've had contamination like hypergolic fuels or ammonia on space station. The same thing applies. I can significantly reduce the surface area that I have to worry about in coming back into the spacecraft. So I get that, and then consumables. The smallest airlock we've had on shuttle is about 150 cubic feet. So on shuttle, we just let that gas go to space. On space station, we have a pump that pumps it back into space station. With Suitport, the volume between the suit and the spacecraft that I have to depress is about 1 cubic feet. So say I put 2 people out, that's 2 cubic feet. That's a factor of 75. So I significantly reduce that gas, and I don't really care if you're talking about whether I vented it to space or whether I use power to pump it back into the spacecraft. Either way, I saved that consumable.
Sure.
So I can significantly save consumables. We get one side benefit of being able to go out and do very, very short EVAs. What we find with the 7-hour EVAs, sometimes maybe something will be rubbing somebody's elbow or something. And by the time they come in, it's a hot spot, and they might need to put a Band-Aid on it or something like that. What we find over in the water tank is if I can limit their EVA duration, then those hot spots never develop because they're not in the suit for 8 hours, 9 hours. And so if I can get them in and out that quick, if they start seeing a hot spot, they can put a piece of tape on it before they get in the suit, and we'll alleviate that whole irritation to the crew.
Sure. I understand the spacesuits aren't the most comfortable garments to wear, so.
The spacesuit people would like you to not know you're wearing a suit. That would be ideal, but we're not there yet.
Yeah, exactly. So, and I think the last part of this, and I think you did answer this, was basically if the suit could be used for more than one mission.
Yes.
So, congratulations on the testing and the good results that you have and continue with. But let's go ahead and talk to me a little about what's next for the Suitport.
So we built the Suitport based on the Marmon clamp, and we like it. It's our second generation Suitport we've built based on Marmon clamp, and we about halved the part count between the first generation and the second generation. But while we've been doing this, someone came up with a good idea for what we call a pneumatic flipper Suitport, and that Suitport cuts the part count again, maybe by 75%. So we've been building that. It's in the lab being assembled now. We're going to come back in August and test that Suitport, and we're going to decide which clamping mechanism we prefer. When we're done with that, we're looking to, right now the testing we're doing has the chamber at about 21,000 feet altitude and the manlock at sea level. That gives us about an 8 psi delta across the suit. What I want to do is come back and take the chamber to space vacuum and hold the manlock at 8 psi spacecraft pressure and go ahead and repeat this test with the crew member at vacuum and with the chamber at vacuum. And that will truly show, hey, we're ready to start integrating with a spacecraft. Assuming we can do that, our Advanced Exploration Systems, Advanced Extravehicular Mobility Unit group is trying to have a prototype suit ready that could go to thermal vacuum. That's where we pull the chamber walls down to minus 300 degrees. We put heat lamps in to simulate different environments, and we have the crew member walk into the chamber, and it's a big deal. It's almost as hard as a space EVA, except we don't have to get there. And we'd like to see Suitport be part of that test when they do that in, say, 2016 or 2017.
Wow, fascinating. Extravehicular Mobility Group, that's a mouthful. Only at NASA.
So I would have said at AES EMU. Oh well.
So again, congratulations. A lot of work has been done, a lot of work still to do. Thank you guys for your questions. This is Mission Control Houston.